Okay, that pretty much does it for 3.3. We're skipping over 3.4. It's exponential growth and decay. And 3.5, I'll talk about next class. 3.6, I'll talk about next class. We're going to go right to 3.7. So 3.7. L'Hôpital, yep. Okay, this section is called Indeterminate Forms and L'Hôpital's Rule, or La Hospital. It's pronounced L'Hôpital. So the big thing right now for you to understand is we are going to revisit something we've kind of put away a while ago. Limits. Okay? We did limits, right? That's the way we pretty much started the class. I told you, to me, Cal 1 starts at the limit. So we did some limits, we did some stuff, we came up with this idea of the derivative, right? And then I gave you these rules, and that's what we've been doing, right? All the product rule, quotient rule, chain rule, and then all this other stuff. Implicit differentiation, logarithmic differentiation now. We saw how we could use it to do some word problems. That's what we've done. Now we're going to go back, and we're going to look at limits again. And we're going to first talk about what indeterminate forms are, and then I'm going to introduce you to a very, very, very nice rule called L'Hôpital's rule. So what are indeterminate forms? If in the limit you get 0 over 0. Remember this? This was like one of the first things that we ever kind of stumbled across with limits, right? We said, oh, the numerator's headed to 0, the denominator's headed to 0, right? So when I put there, if in the limit, this is so important that I'm saying this, in the limit, as you take the limit of something, you get something that looks like 0 over 0. That's what we call an indeterminate form. We can't tell you what the answer is until we do what to it? What did I always tell you to do once you had 0 over 0? Some sort of algebra, some sort of trick, right? But we may or may not be able to get an answer, but I can't tell you right off the bat. If it's 0 over 0, I can't tell you. I can't determine the answer just by looking at it. I have to do something. So it's indeterminate. What's another type of form that we saw where we had the same thing? Yeah, infinity over infinity. That was another indeterminate form. And you can even put plus or minus on both of those. So like you could have positive infinity over negative infinity, or the other way around, negative infinity over positive, or positive positive, or negative negative. It doesn't matter. Those are still indeterminate forms. The numerator's getting huge, denominator's getting huge. Who wins? Well, we have to do something to figure it out. What are some other things we ran into where we couldn't quite tell? We had fixed over 0, but that one did give us 3 answers, didn't it? It was 3 possible things, remember that? Fixed over 0 gave us either infinity, negative infinity, or does not exist, right? So let's hold off on that one. Anything else? Fixed over infinity, that went to 0. Remember, anytime you had fixed and the denominator gets big, that went to 0. So that we could determine, right? The answer was 0. There you go. Infinity minus infinity. Right? What's infinity minus infinity? Don't know. Right? Don't know. Those are the things we've seen, right? Anything else that we've seen? I'm thinking out loud here. I don't think there's anything else. Oh, well, no, we didn't see that. Okay. So I think underneath each of these, maybe give you an example. Okay, I'll give you an example. Anyone else need to sign in? I'll give you an example of each of these. How about limit x goes to 0 sine x over x? That equals 1, right? Because I told you it does, right? But isn't that giving you the form 0 over 0? Okay. How about an infinity over infinity? Something like limit x goes to infinity, x squared plus 1 over 3x squared minus 1. That goes to infinity over infinity, right? Remember how you would do that one? Divide the highest power of x out. Okay, good. And then something like this. Limit x goes to infinity, square root of x minus x. You had a quiz or test problem that was like that one. Again, infinity minus infinity. And the way we did that one was we factored out like a square root of x and then made it multiplication. Okay, so that's just me reminding you of some of the things that we've seen. Now I'd like for you to consider some other forms that we have not looked at that are also indeterminate forms. So here are the new ones. 0 raised to the 0. Now let's consider why that's an indeterminate form. And I'll put an example below it. Limit x goes to 0 of x to the x. Now what's the problem with that? I mean, why is this an indeterminate form? The base, right? The x is the base, right there. That wants to be 0, doesn't it? It's trying to go to 0. But then you're trying to raise it to the 0. What is anything raised to the 0 supposed to be? 1, right? So the power is trying to turn the answer into 1, but the base is trying to be 0. So it's like this tug of war. Do you all understand that? So you can't just look at that and be like, oh, it's 1 or oh, it's 0. It may turn out to be something completely different. Just like 0 over 0, we couldn't tell. Okay, so that's a new indeterminate form, 0 to the 0. Here's another new indeterminate form. 1 to the infinity. So here's an example of this. Limit x approaches 1 of x to the 1 over 1 minus x. And let's say x from the right, just so I'm technically correct. What does the base of that want to be? What does the base of this want to be? Where is x approaching? 1, right? So it's getting closer and closer and closer to 1. Now, is it actually ever getting to 1? No. Now let's talk about the exponent. What is the denominator of that exponent right there? It's going to 0, right? So you have fixed over 0. Fixed over 0 is going to wind up going to infinity, right? You know what? I need to change something. Flip the order. X minus 1 instead of 1 minus x. So what would happen here with our exponent, the bluish part, is that it's fixed over 0, and if you did that work, you'd realize that that goes to infinity. So you have something that's trying to be 1 raised to something that's trying to be infinite. So when you take a number that's a little bigger than 1 and start raising it to powers, shouldn't it try and get bigger? Yes? Like take the number 2 and start raising it to higher and higher powers. It gets huge, doesn't it? So get closer to 1, like 1.1. Well, if you do 1.1 raised to a big number, it's going to get big. So the base, the yellow, is trying as hard as it can to be 1, and the exponent's like, no, I want to rip you apart. I want to blow you up. Right? Do you see that? It's, again, a tug of war. Do y'all follow this or not? It's kind of abstract, but how about this one? Infinity to the 0. What's the problem there? Without me giving you an example, what do you think the issue with that is? Yeah, the base wants to be huge, right? Like, let me become infinite, but the exponent's like, wait a minute, hold on. I like to turn things into what? 1. So who wins? You see the kind of the conundrum, the problems we have here? Let's see. Trying to think if there's any others. Can you all think of any others? Can you all think of anything that might cause an issue? Hold on, let me go with the first one I heard. 0 or infinity times 0. That's a good one. Because what happens is the factor on the left wants to become huge, right? But the factor on the right wants to become small. Do you understand why it's so important for me to have set up here in the limit up there? Because I'm not saying 0 times infinity is something we don't know. I'm saying something that gets huge times something that gets small we don't know. I say this because I had a student years ago who called me 2 years after Cal 1 and was like, you told me that this, and I was like, I never told you that. I said, when you take a limit and you get something like this, that's when this happens. You know, if I just say right now, what's 1 billion, gajillion, gazillion, gazillion raised to the 0? What's the answer? 1, okay? That's different. A number to 0 is 1. But infinity to 0, that's an idea. That's a concept. All right. So we don't know who wins 0 times infinity, or doesn't even matter. It could be positive or negative infinity. That doesn't matter. Anything else? One raised to infinity. But see, 1 raised to infinity, we don't even know what that does. And then you raise it to 0, you still, yeah. I mean, so that would be like 2 of these together. We're trying to get like the most basic forms that we could get, and then of course they get more complicated. What I've found in the past is that students kind of think that everything that has zeros, ones, and infinities works. Like that's indeterminate. Like let me put some down here. Oh, new page. Let me put some down here and see. How about infinity to the 1? So the base wants to do what? Get huge, right? What does raising something to the 1 power do? It just leaves it alone, doesn't it? Like 4 to the first power is 4. So the base is like, I want to become infinity, and the exponent's like, shit, go ahead. That's what I want you to be. I want you to be whatever you want to be, right? That's what I'm going to let you be. So there's no like conflict here. The answer to this would be infinity. Do you see? How about infinity to the infinity? Base wants to be big. Exponent wants to make it go there faster, right? No problem. So infinity. Trying to think of different ones that students will turn into problems when they're not. 0 to the 1. What does the base want to become? 0. What does the exponent want to do? Just leave it alone, right? Let it be. It's fine. So the answer to that one would be what? That would be 0. This one would go to infinity. This one would go to infinity. Oh, how about this one? 0 to the infinity. What does the base want to do? Get small, right? Go to 0. What does the exponent want to do? Be careful here.